Hey guys, what is up? Welcome to episode 8. And if you haven't noticed, I actually bumped up the font size just a little bit, hoping that maybe you guys are going to be able to see a little bit better. A couple people commented, and I figured a good balance instead of zooming in the camera all over the place, because I myself don't like when tutorials do stuff like that. I figured this might be a kind of fair trade-off. So let me know what you think if this is a little bit more readable. I bumped it up from a font size 10, I didn't realize how small it actually was, to 14. So hopefully that works. One thing I did notice, we have UseGL 2.0 as true here, but for the Android and everything else, we actually have it set to false. So we should probably go ahead and update those. Make sure we save our changes, and that way we don't get, well, we won't worry about the GWT right now. Actually, I wonder what else, if there are any CFG options for this. Let's see. Use debug GL. Nope. The frame rate to run the game at, so we can set stuff like that. Whether to use a stencil buffer. That sounds cool and fancy. Alright. So we'll leave it at that for now. And basically, what I would like to do today are hopefully add some enemies. I figured that might be kind of a fun thing to go ahead and knock out. Let's see actually where we are so far. If we get this running, so we have this, we have our controls so that we are moving around, but you can see that it's fixated basically around here, and our camera is following us around, so it doesn't really look like we're moving anywhere, but we are moving in space. So let's fix this a bit, and I'm thinking about changing up the tutorial style just a little bit. It's because I feel like it's gotten too much do this, then do that, then do this, instead of actually learning anything. So yeah, but for the world render, let's go through here and see what we can find. For our draw, we have get X, get Y. Let's see what parameters it takes. We have texture, we have float XY position, we have the origin XY, the height XY, the scale, the rotation, the source X, source width. So the origin width and height should actually be, I suppose, ship texture. No, ship dot get width, and divide it by 2, so that should work. Let's go ahead and see if that gets us up and running. There we go. So you can see we're no longer rotating around this point, we're now rotating around this point right here. Now this is kind of going to cause a little bit of a problem if I'm thinking ahead correctly, but basically our game has us rendering our ship here, when in reality our game logic still sees it as being up and over a little bit, basically around this point. So what is the best way to solve this little dilemma? Let's do this so that we can better see it. shape render. And this is a kind of helpful class to render shapes, in case you couldn't get that from the tape, or from the name. Late night again, shape renderer, just that. Okay, so we can do sr dot begin shape type, and this is going to be a rectangle. And I feel like there's some stuff we should probably set up here. Sr dot set color to color dot, let's use cyan. Cyan's a cool color, right? What else do we need? We should probably set the projection matrix to camera dot combined. All right. So dot, let's see, a box isn't what we want because that's for 3D. We don't want a filled rec, we just want one of these. Ship dot x, and so I'm going to go ahead and write this out and then kind of explain how it works. Alright, so basically we're creating this shape renderer, which just basically renders basic shapes, triangles, rectangles, circles, if we're dealing with 3D boxes, but that's about it. And so here we are setting the projection matrix to camera.combined. I actually want to get a little bit more into matrices later because I want to learn about them myself, because if you want to do anything 3D, you have to basically know matrices inside and out. And so I got a question about 3D, and it's a question that I'm actually really curious about myself after it was asked of me. So I want to learn about that. But then we basically, like we do for a batch where we call batch.begin, we're calling the shape render.begin, but we're telling it what kind of shape we want. We want a rectangle. So after we tell it what we're drawing and we begin, we actually draw it, and we're drawing it at the x, y, and then the width and height of the ship, and then we're calling it .end. So hopefully this should draw a rectangle around our, there we go. So basically, and if you're seeing how this is moving a little bit, I don't know if you guys can see it, but it's moving basically one pixel at a time, kind of back and forth. That has to do with our movement, I believe. So that's actually, so now you get an idea, and we can actually, we'll actually use this once we start getting into like bounding our hit detection and bounding boxes and stuff like that. This will be really, really handy for us to be able to visualize that. So you can see it drew a rectangle at our position.x and our width and our height, and it basically outlines our texture perfectly. So yeah, it's really handy for debugging purposes. I highly recommend not using it for final releases because it does slow your game down just tremendously. Like, it slows it down like no other. Well, I shouldn't say like no other, but your frame rate will take a massive hit. And actually, if you guys want, if we go back to Angry Masons here, let's do this. FPS logger log and log equals new FPS logger. And then we need to do our import, so there we go. And then we can just say log dot log. Easy enough to remember, right? And then this should, if I'm thinking correctly, should output our frames per second down there. And there, mine are kind of low because I'm assuming because I'm recording. My recorder takes a whole lot of processing power. That, and because we have VSync on, it doesn't show it here, but it's automatically on. So if we put VSync enabled to false and now run that, we should get a much different frame rate. Yeah, there we go. And there you go. Now you can see that I'm up over 300, 200 and some FPS, and I would be quite a bit higher if it wasn't for xSplit. xSplit uses quite a bit of my processing power. In fact, it actually tries to bump me back to the slow PC version of Windows 7, which is crazy because I have a fairly fast computer with a fairly good graphics card that runs everything at very high settings. Usually max settings, it runs everything over 60 frames per second easily. So I digress. But there we go. And if you guys want, we can take a look. This is always, it's kind of fancy, and I shouldn't say fancy, but it's kind of a good habit to get in when you're learning something, I suppose, to look at the methods and stuff, that variables that are available to you. Well, let's see. Like this uses CPU sync. This can be kind of handy when mixed with different vsync stuff if you read through there. The use GL 2.0 is, we're using it now, but it's also very, very important. You can add an icon, which is to display in your little thingy, which we might do later once we get stuff later. The setting from display mode is kind of handy. Yeah, we'll leave. You guys can look through that. I don't want to waste too much time because we have a lot of stuff that I'd like to get through today. So we've got that going. The other thing is with our ship, I totally forgot to do something for the update. First, on our update, well, even before that, I need to say on our creation, I need to say if we go up to an entity, we can see we have bounds. So we need to set, does bounds get created? Yes. So we have that, but we actually need to reset our, so we've got that, so I don't need to do it in the constructor. But we need to set it when it moves. So we can say bounds dot x equals position dot x and bounds dot y equals position dot y. And because our width and height are basically going to stay the same, I mean, I don't foresee us needing to scale that stuff up right now, but should we have to at some point, it's always an option. We'll add that in later. I mean, it would be as simple as saying bounds.width equals width or something like that. I think that's what we have our variable set to. Yeah. I mean, it would be that simple should we need to do it later. But we don't need to for now, so that's just trying to make it more readable. Alright. Now, let's see, what do we want to do? Okay. now we're going to create our first enemy, and I'm going to call it a follower. So I'm going to say follower, that's in the package, and it extends movable entity. Pretty fancy how we did all these, you know, all this inheritance. It really helps kind of speed up the process later on. So we do this, and on update, you see I'm not really liking how I did the update method, because the movable entity, instead of having an update, it should actually go update ship s. It doesn't need to. It needs to take ship. That way, these have access to the ship, and we'll see why that's important in a little bit in a minute. But we're gonna end up bugging this. All right, but ship's gonna get mad at us because we don't implement. So we'll just throw that in at the bottom as a blank stub. I don't like doing that, but I'll think of a better way to deal with that later. How I want to deal with it. I don't want to keep making subclasses of subclasses of subclasses, because if we wanted, we could even make an enemy subclass, which might end up being done. It's definitely possible. So, not to get your hopes up or anything, or get you feeling upset about it, but so we don't forget, let's just do this. And actually, you know what? No, that's silly. Yeah, actually, let's go ahead and do it. Because we can actually just do this and write it once in, say, movable entity, instead of making this abstract. Bounds.x equals position.x, and bounds.y equals position.y. And then if we do it that way, then all we would have to do instead of doing this would be call super. Well, it would be this dot. Wait, what's the correct way to... There, like that. And then that'll automatically do the setting the position and stuff for us. Fancy, right? Won't worry about it with the ship. We'll leave the ship as is. Actually, we no longer need to override that either. Kill two birds with one stone. Alright, so the follower, we're going to have the position, we have a velocity, so we need to velocity, and basically I'm calling it a follower because I want it to basically follow your ship around, kind of being a big pest. So we're going to use the lerp, and the target is going to be ship.getPosition. And the alpha for now, we're just going to use this. Basically, we're going to interpolate from the velocity. Wait, I don't want to use the velocity. Actually, I want to use the position. All right. I'm really hoping I'm doing this the right way, because going back and dealing with all this is going to be fun stuff. Um, Now if we go back to the world, now that we've got a follower, just to test this out, we can say follower, man, if I can spell follower. And it's basically going to take the same parameters as the ship. Say 10, comma 10, 1, comma 1, comma 0, 5F. And we need to import it. And what did I forget? Oh. Float, 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 vector 2, float, float. Wait, so we have speed, rotation, width, height, position. Speed, rotation, width, height, and position. And to make this easier, I'm actually going to add some JavaDoc to that later. So it tells us what the parameters are. Oh, well, there it tells us. But still, it's not all that clear. And then let's get something where we can return the follower. All right, to return the follower, and for the update, we'll send it the ship. And you see we had to send it the ship. That way it knows where the ship is to follow it. And a lot of the enemies are going to need to know that for AI purposes, whether it involves shooting something or whatever. Now we have to go to the renderer. And we're going to have not only a ship texture, but a follower texture. And the follower texture, which I've already made from a game a while back. Data / follower.png. We don't have to worry about setting that. Is actually going to be this. Let's see. It should be on my desktop, which means it's going to be hard to find. There it is. So we have this enemy. We bring it up here and drop it into our assets, which it's called enemy, and we need to rename it. You guys won't have to do this, but because it should all way to be done when you guys open up the repository, that way you guys have all the images at your fingertips without having to remake anything. All right. So now we need to draw it. And that's totally not the one I wanted, but that's okay because we can just follow along up above. So we have we need that. We need to import it. That way we can store it here. Because it's called follow. There we go. follow dot get position. So we're just basically gonna follow along with what we did with the ship. And my goodness, I have bad habits. By 2. And then we have the width and the height. And then the scale. Then we have the texture region. There. Right? Yeah. The width. This method is just takes so many parameters, it is ridiculous. But it's really nice, because it gives us a lot of ways to manipulate our image when we're rendering it. Alright, so there we go. We can now see that we're actually can move away from the enemy and that he can chase after us. Although I don't really like how it works right now. I don't like using the lerp function for this. So that'll be changed. But we have something for a rough idea. But the other thing is, this enemy I didn't make to stay static like that. And I should probably even change. I should probably copy that instead of for this, because it doesn't really look all that good. Like that. But the other thing on the update with it, let's see, what do I want this to be? GDX dot get delta time times rotation speed. And we can actually go ahead and create alright, so and we'll just say if rotation is greater than 360, rotation minus equals 360. That way, if it gets higher than a full circle, we just knock it back down. And it is indeed rotating now, but at a speed that is so slow, it is painstaking. So let's knock this up to 500, so we can really see some spinach going on. And there we go. Now that looks a whole lot better, but I still don't like the texture filter on that. Still looks a little bit sloppy, so it might actually work better if we go back to our renderer to be texture filter dot nearest. Let's try this. Now if we go ahead and run this, let's see if it looks a little bit better. Nope, that made it look worse actually. Alright, so we're back to that. So we have those two things. Now, let's go back to our world, and we want to know if they hit. So this is why we have the bounds. It makes this really easy. Bounds dot, I don't want it to get the class, dot, why? No, I really just want, there we go. What? why are you doing this to me? There we go. Overlaps follower dot get bounds gdx dot app dot log. Whoa, ship hit, we're taking damage. Okay. Yep, that just happened. Let's look for it down here. Oh, yep. So there we go. Our ship is getting hit. A lot. A whole lot. Now, to make this a little bit clearer, let's go to, instead of drawing, let's go back to our world renderer. Instead of drawing the ship dot get position, change it to get bounds. Get bounds dot x. Get bounds dot width. And get bounds dot height. So dot set color. And I'm setting this here so that it makes it a little bit easier to see the difference between the two. But we're also going to draw another rect. This is going to be follower. Well, it's follow dot get bounds dot x. Wow, I actually out-typed the IDE. There we go. Get bounds dot width. Okay, now I almost slipped up and fell into an old habit, but we not only can you access the public variable height, but you can also access a getter, which is get height. So it's up to you how you want to do it. I'm pretty sure the performance difference between the two is actually negligible, if anything. I might not be the best person to say about that, but and yeah, shape renderer needs to be disposed at the end of everything. But let's make sure that this is as we think it should be. Boom, and you can see how as soon, now look, we're not getting hit. We're hit. We're hit. And we're hit. So you can play around with that a little bit. That makes it kind of nice to see how everything's working. And when we actually get to do this, our bounds might not actually work that way, which is another reason I just thought about it might be bad the way I called it the super method like that. But the reason being is our texture doesn't fill up that entire rectangle, and it's completely possible that the follower and the ship, based on what we see, can go by and not be hit. But based on the rectangles, because the rectangles are larger than the textures themselves, that those can go by and hit each other, and we get that our ship's been hit even though the two textures never actually overlapped. So game developers account for this multiple ways. One of the most common ways is actually making your hitbox smaller than the actual full texture size. That way, you know if it overlaps, it actually hit your, your texture. That's why in some games you can actually kind of slip by undetected on certain things. So even though it looks like you guys hit, it's because your hitbox is a little bit smaller than the texture, and that's an intentional thing to keep people from all out raging when they play a game, because it gets really frustrating. We can delete that line. It gets really frustrating when you're playing a game and boom, you get jacked up constantly. It's not very fun. But that's going to conclude episode 8. Hopefully I explained how the shape what the shape renderer is, why it's handy for us debugging purposes. I explained not to use it for the final. Let's see, with this I added the FPS log in the main. I played around with the VSync a little bit. I explained that. I explained the bounds. Let's see. For the entity, we changed this up. We didn't change any of this. For the follower, we basically created this whole thing. This part we already know about, the rotation speed. We're just using basic math to add to the rotation every frame, and it's in a frame independent manner because we use the delta time to multiply the rotation speed, which means it'll be spinning the same if our game's at 30 frames per second as it is if we're on 250 frames per second. So we did that. The movable entity, we did this whole thing with updating the bounds, which I haven't decided whether or not I like the way we're doing that yet. And in the world, we just created the follower, and this is code that will not at all be in the final version, but we use it so that we can actually see how our enemy works. So yeah, in the next version, I will hopefully add bullets. That's my goal. Bullets, multiple enemies. Yeah. So that'll be our goal. And hopefully you guys like that as a goal. So I'm gonna test actually what I get frames per second wise once I stop recording and close down xSplit to see actually how much of a difference it makes. But yeah, I will hopefully see you guys soon. And sorry for the late video. I had some major family stuff that came up, so please excuse that. But yeah, episode 8 is out. You're watching it. Hopefully episode 9 will be out not too long either, because it's the weekend, and hopefully I have some time this weekend without it being absolutely crazy. But see you guys later. Hope you guys had fun in this episode of creating a game in Java. Later.